All right, well, we'll get started here. Hello again and welcome to our talk, Unveiling Cloud-Native Operational Excellence. There we go. Unveiling Cloud-Native Operational Excellence, or CNOE, Pioneering the Future of IDPs. I'm Luke Phillips, a staff software engineer at the New York Times.
Hello, my name is Tiara Sykes. I am a software engineer at the New York Times as well.
Before we describe CNOE, we need to go back and share our journey. Our journey began by defining a platform. At a high level, we define a platform in the context of three components: the mission that guides us, the support that enables product engineers to deliver software, and the architecture we build and provide along the way. Given the framework from the previous slide, we'll begin by reviewing the New York Times and its engineering mission statements. At the Times, our mission is to build the essential subscription bundle for every English-speaking, curious person who seeks to understand and engage with the world. We are a digital-first experience, leaning into technology to produce comprehensive news coverage. News journalism is the Times' most recognizable product, with others like games, Wordle obviously, but also crossword, connections, and if you've tried the new game Strands, cooking, audio, as well as Wirecutter and The Athletic. Some of the most popular search terms on Google will lead you to the Times, much like Wordle answers. This generates a ton of traffic for our site. And so next, for the engineering mission. This mission statement is fairly high level, but it ultimately indicates what we are here to do as engineers, which is to build high-quality software that enables our organizations. And while technically excellent software leads to high-quality products, we still often find ourselves at tension with this. We want to be intentional about preserving the time of product engineers, the time product engineers spend building products that serve business needs. Next, we will get into the product of the platform and the support. So let me hand it over to Tiara.
Thank you so much. So as Luke mentioned before, your platform support is your selling point to get product engineers, product managers, and other leadership on board to use it. Some questions to guide and assess the support model could be, what does a platform developer or a product developer want from a platform, and how will they feel supported as they develop new products? So let's share our journey on building our platform support at the Times. So as an engineer, this would be my ideal state of a development workflow. Since developers' focus is delivering features, it's best to have them focus on what they know best: writing excellent quality code, covering it with tests, and implementing it with the best patterns to keep the code base maintainable. However, that's far from reality. After you write code for an exciting new feature, you need to containerize your application, probably provision some infrastructure, to build, store, and deploy the artifact from your code. The story doesn't end here. Even after deployment, there are still routing, DNS, monitoring, and observability. Each of these tasks is huge on its own, requiring a lot of time, effort, and knowledge, understanding security threats, and best practices. This overhead is necessary, though, for the quality of your applications, and usually the software development process complexity grows with the size of your company. In bigger organizations, different teams are responsible for the different boxes on the slide, and you, as an app developer, are responsible for finding the newest versions of the documentation, discovering and adopting tools and patterns, as well as requesting access and permission. So this is where the idea of an internal developer platform catches on. So let's talk about the dream of a lot of infrastructure teams, and I would hope that application teams would agree as well, that the exciting thing which is called Internal Developer Platform, or IDP. An IDP should consist of a standardized set of self-service tools and technologies tied together by platform engineers to provide application developers with an easy way to follow the golden path of building an app. The platform team should treat IDP as a product and provide service for engineers to work on their applications. So in particular, the Delivery Engineering Shared Platform, as we call it DVSP at the Times, is a set of centralized tools and capabilities that provide developers at the New York Times a seamless and productive developer experience. The platform aims to produce centralized code management and deployment pipelines, infrastructure to help run our systems in our cloud, and observability tooling to help teams understand and operate their systems. So let me hand it over to Luke again.
Thank you. Given our mission and support, what is the platform that we actually ended up building? How our IDP journey began, much like yours perhaps. Everyone gets a Kubernetes cluster. Feature teams with a possibly embedded DevOps SRE engineers managing their own clusters, a mix of cloud tools versus self-hosting, some single cluster versus multi-cluster environments, developers responsible for the full lifecycle of upgrades of their infrastructure, etc. Step one of our IDP is the centrally operated and managed set of Kubernetes clusters. Teams and developers no longer have to maintain their own infrastructure, manage the day-to-day of some cloud provisioned Kubernetes like EKS or GKE, which comes with its own headaches. We offer distinct multi-tenant spaces within the clusters. Each team's operations are separate from each other with RBAC and security controls. In a more simplified view, we began to build our platform piece by piece, together bringing together the best of class CNCF and open source projects, Kubernetes as our base compute platform, and a related dedicated team. Along with Kubernetes, you want to add a declarative configuration management tool, following GitOps best practices, and add Argo CD, as well as another dedicated team for application delivery. Finally, we wanted to add a developer portal. Backstage seems like the right choice, as well as another dedicated team. We should also add that there have been an incredible amount of work by our engineers to build the IDP and all the features in between. Custom controllers and automations, the glue that brings a lot of these bits together, observability, reliability, security, networking, etc. We've got to this point in our journey and we're starting to notice that is similar to others. We are at a moment of reflection. What if we had built all of this as one to begin with? You perhaps are starting with a blank slate or trying to figure out the right technology choices to make yourself. Does this journey sound familiar to you? You may find yourself facing these challenges. Do you start with something brand new, a blank slate? Or how do I reduce the number of technology choices I have to make to get to this point? Taking a step back, there are other ways that we have seen this before, a reduced set of technology choices that you have to make. Looking at the most common pattern of a distribution, take, for example, Linux and the variety of ready-to-run distros out there. The Linux kernel is the core with a select source of open source tooling that are packaged on top of the kernel. What if you could do this with a platform? For the case of an IDP distribution, Kubernetes acts as the core and you choose a set of CNCF technologies that sit on top of it to deliver a developer platform. And this is what CNOE sets out to be. CNOE is designed to be built using these open source CNCF technologies to be the packaged distribution of an IDP. Why does a distribution matter? It gets us past technology choices, focuses shift on improving technologies used, and we can all shift to defining best practices. Strategically, this helps your evolution from a genesis towards a production commodity solution. So let me hand it back to Tiara.
Thank you. So we define an IDP and its likeness to a distribution. So let's talk about IDP's capabilities. So this is a capability map, and it's pretty much a synthesis of other capability maps that you see within industry, and it was organized under the CNOE framework. It allows us to look at these capabilities of an internal developer platform, define what they provide, and the integrations between them. And this map should look really familiar. So these are technology choices you face today when it comes to adopting capabilities for your platform. These are CNCF projects, open source projects, vendors, and others all under the cloud native umbrella. As you look, each technology is categorized by the capability it provides and scale based on how widely used it is in industry. So it gives a great overview of how popular these technologies are. However, there is no real way to gauge how well these technologies work together. It's a classic tale of spending time and effort, placing our bets, and hopefully winning big. Sometimes, though, you may have to go back to square one if the technology does not meet the need of your platform. So here is an example of a subset of technologies that can address the requirements for capabilities on this map based on the CNOE framework. This is a curated suite of technologies that were chosen because of how seamlessly they work together. And this subset hopefully takes away that pain point of having misplaced bets. Just to reiterate, though, that this is just a recommendation of technologies to use for your capabilities. So if you don't use them, no need to worry. But if you're interested, please look into them. If someone is just getting started or in the early stages of building their platform support, this is a great branching off point of having already predefined tech stack to work from. And then comes the lovely question of standardization versus autonomy. With standardization, we're providing choices for product engineers. Select tools, select versions, select program language, frameworks, processes, and whatnot, with the hopes of reducing our time spent on maintaining, upgrading, and security management. However, the benefit of autonomy pushes for innovation and allows product teams to deliver interesting products, hopefully revenue-driven as well, for the business. So it brings the question, how can we make our lives easier as maintainers while also not stunting our product team's innovation? So platform engineering is the practice of identifying the building infrastructure abstractions that meet the requirement of product engineers and your business to enable efficient, cost-effective, and successful adoption. These requirements of product engineers and larger businesses are unique, though. Some product teams may want more infrastructure control, whereas some business may have more stringent compliance requirements. However, there is no one-size solution for this process. And it goes back to how we initially defined a platform. You are guided by your principles and missions to answer this question. How you support developers will depend on how you answer this question. And part of your technology choices will be influenced by this question. And I do appreciate this visualization of getting from point A to point B as a product person, rather than walking on a tight line of predefined choices where it's very limiting. Think of it as building a bridge, hopefully a sturdy bridge with nice guardrails to help them get to their end point, while also making sure we're not nosediving to support their decisions. So, more than just principles and architectures, though, CNOE provides a practical tool set to iterate on this distribution concept. So let's start by visiting the CNOE project on GitHub. As you can see, there are several repos that are owned and maintained by CNOE. So let's dive into the IDPBuilder repo and see what it offers. So the IDPBuilder does as the name implies. It builds an IDP based off of the technology choices made for this distribution. The CLI will help bootstrap and get running on any Kubernetes platform the basics needed in a GitOps-powered IDP. There are several examples in the repo to help provide an idea on how all the technology choices work together. So this visualization pretty much tells you what an IDPBuilder does. It's a two-phase core that integrates CLI for setup and Kubernetes controllers for application management. It helps automate environment setup so that your local dev environment is prepared and helps enhance the developer efficiency. Allows for custom package deployments, so particularly allowing for specifications of custom package directories for simplified application deployments. Integrates well with cloud-native tools, so it utilizes Git, Ingress Nginx, and Argo CD for comprehensive development and deployment workflows. And finally, local syncs with GitOps. So supports local directory syncs with the CNOE URL with Argo CD for consistent development to production workflows. So here is what happens when you do a basic deployment to the clusters through Backstage following the reference implementation in the repo mentioned. Backstage creates a Git repository that then pushes the templated contents to it. Backstage then creates an Argo CD application and points it to the Git repository. It then registers the application as a component within Backstage. Argo CD then takes that deployed manifest and stores it in the repo to the cluster. And Backstage retrieves the application help from Argo CD API and then displays it. But we can see this in action in our demo that will play for sure.
Like if you just click again.
Lovely.
There we go. Can I hold that? So in this demo, what you're going to see is a quick git clone of the IDP builder, and we're going to build the CLI tool. Then we run the create command. The create command will set up your standard Argo CD, get T, and backstage environment. For this, we're supplying a reference YAML that will also include Argo workflows, Spark, and Crossplane into your IDP cluster or IDP environment. Once the IDP is instantiated, we can log in and view the various components, like get T here. You will be able to see everything is fully GitOpsed, fully visible, all the config is there, nothing is hidden away in this IDP builder executable. And so from this, you can pivot and log into Argo CD, and again, see how Argo is deploying everything. So the IDP builder simply gets Argo up and running, and then Argo does the rest for your platform, getting Crossplane and all the other components up and running. Finally, you can log into Backstage. This also has a reference of a simple SSO type experience with Keycloak, but again, bring your own if you need. But you're able to see Backstage here, and you can log in and create a kind of hello world application. There's a couple of application templates already loaded in. Everything in Backstage and in this environment is completely API and CRD driven, so you're not editing Backstage templates or anything. You're using Backstage scaffolding CRDs instead. Here we're creating a simple application with a storage component to it. So once the app is instantiated, we can go see it, get set up both in Backstage. We can see the Backstage dashboard here for it. You'll get to see like the Argo status as integrated in Backstage. So this reference also includes a nice way to see how all these technologies work together. You can see the relationship to a storage component. We can dive into Argo CD and also see what was deployed in the cluster, including your S3 bucket as managed by Crossplane. And it's, again, all just kind of working through GitOps all together. Finally, we can go back to Git T and see the GitOps managed configurations. So you can see the new Git repo for this instantiated app. Nothing is hidden in Backstage. Everything is available right in the Git repo. Note in this demo and usage of IDPBuilder, it's a great way to get started and seeing how all the tools can integrate together. Don't run this in production. You will need to evaluate your own security concerns and architectures. And looking back at that earlier reference diagram, what fits, where you need to adjust. And for example, like myself, I would not use the administrative tokens this comes with in all the integrations, like Argo admin is controlled by Backstage. You need to figure out all the better security hardenings across all the tools. But again, this kind of gets you started. But I think I have one more demo. Yes. One more demo that we have wired up as well. There's another CLI in the CNOE project called just CNOE CLI. And this tool will help you create the Backstage scaffolding CRDs for your own CRDs. So in this demo, I'm taking a custom resource we have built in-house. This manages all of our networking resources in our multi-tenant cluster. So here's an example of that CRD, not the full spec, just 10 lines out of 3,000. Using the CNOE CLI, this will template for me the Backstage scaffolding CRDs. Once you have that, you can cat out here real quick what the Backstage CRD looks like. It's interpreted my CRD, turned it into this. You can then git push it, Argo CD deploys it into your cluster, Backstage understands all of those CRDs, and you can then instantly go over to Backstage and see our own resource can be instantiated now through CNOE. So it's not fully canned demo. We got something real running. And so, back to Tiara.
Thank you. So how is CNOE progressing? So there is a governance model that pretty much documents the decision process made within the CNOE community. If you're interested in learning more about why these choices were made, On top of that, there's project roadmaps so that you can understand what are some future initiatives that will come down the line. On their website, you can learn more about these capabilities in details, find and read their best practices that they recommend, as well as some demo and templated out example code. There's their bi-weekly community meetings also listed on their website, so please feel free to attend those and check it out. And lastly, the CNCF Slack channel, in particular the CNOE interest, where you can submit any questions or like comments. But I mean, I feel like one of the greatest ways to also contribute is looking at filing issues on GitHub to related to how you operate your IDP, with the theme of today being collaboration and building and growing a community. This is a great way for us to learn and grow together in such a complex problem space.
And so in conclusion, like Tiara was just saying, so much of this really does depend on our collaboration, that we not need to reinvent the wheel each time for IDPs, but rather can collaborate on what should be a good distribution of these tools. We want to build technology in a way that builds community by sharing knowledge and working together. And so thank you for coming to our talk.
Yeah. I do want to give a special thanks to those in the CNOE community, especially those listed that helped put in the work and supported us in preparing our slide and talk. So, and feel free to connect with us. Our socials are linked on the slides.
Or if you subscribe to the New York Times, you can reach us there anytime. Thank you again.
A few minutes for questions.
Yeah, questions? Just left them stunned?
Oh.
Yes.
Yes.
I have a question. Do you see CNOE as a blueprint, or will this eventually you see this as the thing that everybody implements rather than our own IDPs?
I would see it more so as a guided blueprint. I wouldn't see it as like the solution. Like I mentioned before, like your platform will depend on your product engineers' needs as well as your business needs. So it's a great starting off point in terms of framing your initial conversations of building it up and like your road mapping for the future. So that way you're not going down the windy road of encounter a problem, trying to figure out the solution from there. It provides that holistic overview so that you at least get your GPS navigations on track before you start the journey.
And the organization and project is pretty young still, so again, this is the chance to get involved if you have, like, if you want to steer it towards what you want to do. This is a good chance for that, and it might get closer to what you're asking there. But yeah, that discussion is open. Yeah. Anyone else?
I'm curious what you think are the first steps when you have, maybe you do have like a cluster for a developer, and there's maybe not great impetus within the org to like change that, or the friction is hard to identify, and what's a good first step to try and like begin that transformation?
Good question. As far as like getting the developer from kind of owning his own application to kind of sharing the cluster and the platform kind of thing.
Giving up that individuality, giving up that like control that they have.
You just give them the pager at 2 a.m. and say, "Do you want to run this?" I mean, that's kind of the right balance of motivation as far as like, can you run this versus someone or a group of people that might optimize it. There's only limits to what you can scale on, and what is the best way for you to spend the next hour of your time, this next unit of time. Is it keeping this going, or do you want to kind of scale with something that can be optimized for a larger audience? Yeah. Anyone else? Nope. Cool. Well, thank you again.
Thank you.